This video we are going to discuss about derivatives, okay, and this is exercise 13.2 of NCERT textbook of mathematics class 11. Okay, so suppose we have a function f from set A to B. Okay, so here A is the domain, B is the codomain here. So then such that, suppose this is a function such that y is equal to f of x, where y belongs to B and x belongs to A. Okay, then you see, for a small increment in x, so y is equal to f of, for a very small increment in x, suppose del x. Okay, del x be a very small increment, so increment in y is suppose del y. Okay, suppose del y. Then how to find the ratio of increment? So here you see, this is suppose equation number 1 and this is suppose equation number 2. If you subtract 1 from 2, then what you will get? So if you subtract 1 from 2, then here y will be cancelled. We're gonna have del y is equal to, on the right hand side we will get f of x plus del x minus f of x. Okay, then what will be the ratio of increment? So del y by del x, so divide each side by del x, then you will get f of x plus del x minus f of x divided by del x. Okay, so where we can write del y is increment in y and del x is increment in x. Okay, so hope you have understood this. So due to the increment in x, there is an increment in y. Okay, so this is the del x is increment, so let me write it again, increment in x. Okay, so then this is called the ratio of increment in y to the increment in x. Okay, increment in y to increment in x. Okay, so now limiting this ratio as del x, where it is very small increment in x, such that we can say x tends to 0. Okay, is defined as the derivative of the function f. Okay, or not or, and it can be written as, so let me scroll up the page. Okay, can be written as, so dy dx, or you can write as y dash, or you can write it as f of x dash f dash x is equal to limit del x tends to 0 f of x plus del x minus f of x divided by del x. Okay, so here you see this is the definition of derivative of a function f of x, okay, which can be written as f dash of x, okay, is limit of f of x plus del x minus f of x by del x when limit x tends to 0, okay, del x tends to 0, not only x, sorry, del x tends to 0. Okay, so we have already discussed about limits, so you must have the knowledge of limit. Okay, so I would like to request you to watch my previous videos which are made on limits. Okay, I will provide the links in the description box. Okay, so now you see this also can be written as, usually we used to write like this, y dash or f dash of or dy dx, whatever. Usually we used to write, instead of del x we used to write h, isn't it? F of x plus h here minus f of x by h. Okay, usually we used to write like this. Okay, then one more important thing here, derivative of a function of a function f, suppose of a function f of x, you can write here, at a particular point, suppose x is equal to a, is given by f dash or a here. Now limit x tends to 0, sorry, not x, so let me write here h tends to 0. So instead of a plus h, here we are going to write a plus h minus f of a by h, or it is also given by f dash of a limit x tends to a f of x minus f of a by x minus a. Okay, it is also can be calculated like this using this. Okay, so if you use this, you're gonna have the same result, and you can use this as well. Okay, then also you will get the same result. Okay, so hope you have understood this. So what is derivative, and what is the derivative of a function at a particular given point, how to find it. Okay, we have got this. So now here you see, when we find this method, this formula that, sorry, let me take this one, when we use this to find derivative, this is nothing but this is called first principle. Okay, this is first principle. This is first principle to find derivative. Okay, so using this first principle we can find derivative. Then we're gonna have some standard derivatives as well. We must remember those derivatives, and we can prove that prove the standard derivatives using this first principle. So now let me tell you what are the standard derivatives. Okay, what are the standard derivatives? We must remember. Okay, so those are, first, suppose we have function y is equal to x to the power n. Okay, then dy dx of let me write like this instead of writing like this. So differentiation or derivative of x to the power n is always n x to the power n minus 1. Okay, n x to the power n x to the power n minus 1. This is the derivative of x to the power n. That means you have a function y is equal to f of x, where f of x is equal to, suppose, x to the power n, then dy dx is given by n x to the power n minus 1. Okay, so if you want to prove, then you can prove using first principle. I will show you. First, let me tell you all the standard derivatives, then I will show you how to prove those. Okay, I'm not going to show all the proofs, but I will show you 2 or 3. Okay, number 2, again here you see, let me take ddx of, or derivative of, e to the power x. This is exponential function. Okay, e to the power x. So differentiation of e to the power x is again e to the power x. If you have, and also you have to remember, if you have ddx of e to the power, instead of only x, if you have, suppose, mx, where m is any constant, suppose, where m is any constant, then its result will be m e to the power mx again. Okay, where m is any constant. Okay, and one more thing, differentiation of any constant is always 0. Okay, number 3, ddx of, or derivative of a constant, only constant, that is always 0. Okay, remember that also, that's also very important. Okay, now let us take now. Okay, now we have taken exponential function. Let me take one more function, important function, that is number 4, differentiation of ddx of, suppose you have a constant and a power on it is, suppose, x. Suppose you have a to the power x. Okay, a to the power x, then its result will be, derivative of this will be, derivative of a to the power x will be log of a base e into a to the power x again. Okay, and instead of this, if you have suppose derivative of a to the power mx, instead of x, suppose there is mx, where m is a constant, suppose, where m is a constant. Okay, then what will be its result? Then it will be equal to m log of a base a, sorry, not base a, base is here e. Okay, then into a to the power mx. Okay, so here a is greater than 0. Okay, remember this, a is greater than 0. Now let us take logarithmic function, and derivative of logarithmic function, ddx of log x. So what will be the derivative of log x? That will be 1 by x. Now let us know some derivative of trigonometric functions. Okay, so ddx of, or derivative of sin x, is always cos x. Then next, derivative of cos x is minus sin x. Okay, then derivative of tan x is equal to sec square x. Okay, then derivative of sec x is tan x sec x. Okay, tan x sec x. Then number 10, derivative of cos x, sorry, not cos, cot x is minus cosec square x. And 11, derivative of cosec x is minus cot x and cosec x. Okay, so along with those, you also you must also remember this. Suppose, let me take some space here. Derivative of, if you instead of x there is suppose mx, where m is constant, okay, m is any constant, then it's going to be equal to m cos mx. Okay, derivative of sin mx is m cos mx. Okay, so similarly here you see, here we have got derivative of cos x is minus sin x. If you need to find derivative of cos of minus cos of mx, okay, where m is constant, then it's gonna be equal to minus m sin mx. Okay, you must remember this also. Okay, so similarly in other cases also we will get those kind of things. Here you see, suppose you have ddx of or derivative of 10 mx, then it will be equal to m sec square mx. Okay, it's very simple, you can remember this. Okay, so hope you have understood this. Now suppose if you have derivative of sec mx, where m is constant, then m 10 mx sec mx. Okay, 10 mx and sec mx. Similarly, if you have suppose derivative of cot mx, okay, derivative of cot mx, then it will be minus cosec square mx. And suppose if you have derivative of cosec mx, then that's going to be equal to minus m cot mx cosec mx. Okay, so let me write it properly. Derivative of cosec mx is equal to minus cot mx and cosec mx. So these are the standard derivatives that we must remember those. Okay, now let me show how to prove those standard results, standard derivatives. Okay, I will show you one or two. Okay, then we will move on to other properties, other rules. Okay, product rule, quotient rules, chain rules. Then we are going to solve the exercise. Now let us prove derivative of x to the power n is n into x to the power n minus 1 using first principle. Okay, remember one more thing here, that is here n belongs to q. That means it may be any rational number. Okay, so let us prove this. So here the function is x to the power n. Okay, so according to the first principle, how to find the derivative of this function is what? Limit x tends to, sorry, not x tends to, h tends to 0, where f of x plus h minus f of x by h. Okay, that's how we find the derivative of a given function using first principle. Okay, so here limit h tends to 0. Here you see, if f of x is equal to x to the power n, then if you replace the x by x plus h, then what will happen? F of x plus h will be definitely, it's gonna be equal to x plus h whole to the power n. Okay, so here we can write x plus h whole to the power n. and f of x is simply x to the power n. Okay, so that's how we can write here. Let me write the h properly here. Okay, divided by h. Okay, so here you see. Now let us put x plus h is equal to, suppose we have put here t. Okay, let us put x is equal to x plus h is equal to t, so that h tends to 0 as t tends to x. Okay, here you can see when h will be equal to 0. Okay, just let me write the h properly. When h will be equal to 0 in this case, then x will be equal to t will be equal to x. So we can say that is why we can say that h tends to 0 as t tends to x. Okay, so now let us replace the h by x plus h, and so doing so we will get f dash of x. So let me scroll up this page, and that's going to be equal to limit. So instead of h tends to 0, we can write t tends to x, and here the numerator will be t to the power n minus and x to the power n, and here as a denominator we will get, instead of h we will get t minus x. Okay, as we have considered x plus h is equal to t, so t will be equal to, h will be equal to t minus x. Okay, so I hope you have understood this. Now here you see, so we have got a standard limit. We have already discussed about limits, isn't it? We have standard limits like this: limit x to the power n minus a to the power n divided by x minus a, where x tends to a is equal to n a to the power n minus 1. Now here you see, you have to consider t as x here. Okay, compare t with x in this limit and compare x with a. Okay, this is t minus x should be considered as x minus a. Then according to this limit we should get n a to the power n minus 1. Okay, so that's why, as we have considered here x as a, so that's why our results must be n into x to the power n minus 1. That's how we can prove. So hope you have understood this. Okay, so similarly we can prove the other standard derivatives as well. Okay, so I don't want to make this video too long, that's why I'm going to skip this part. So that means I'm not going to show all the proofs of those standard derivatives. Now what is product rule? Suppose we have two functions, u and v, both are functions of x. Then how to find the derivative of these two functions, this product of two functions? So here we have to use the product rule, that is first function derivative of the second and plus second function derivative of the first function. Okay, so when you need to find the derivative of a single function, suppose x to the power 3, so its derivative is, so you can just apply the standard derivative ddx of x to the power n, that is n into n minus x to the power n minus 1. So according to that it will be 3 x to the power 3 minus 1, that will be thrice x square. Okay, suppose you have two functions like this. Suppose you need to find the derivative of this function. Suppose you need to find the derivative of sine x into cos x. Suppose we need to find the derivative of this. So in this case, if you have to apply this product rule, because there are two functions as a product, sine x, cos x. So according to this rule, first function sine x, derivative of the second function, so derivative of cos x we know minus sine x, and then plus second function, that is cos x. This is first and this is second function. Then derivative of the first function, okay, first function derivative of second function, then second function derivative of first function. Here the first function is sin x, so ddx of sin x is cos x again, okay. That's gonna be equal to minus sin square x plus cos square x. This is our result, or you can write cos square x minus sin square x. So here we have applied the product rule, okay. So hope you have understood this. Now what is quotient rule? What's that? Suppose we have two functions in this form, u by b, okay, both are functions of x. Then how to find the derivative of this? Okay, this is quotient rule. This is quotient rule. So what is the rule here? Denominator derivative of the numerator minus numerator derivative of the denominator by denominator square. This is the rule. Suppose we have two functions. Suppose we need to find the derivative of e to the power x by x. Suppose x is square. Then how to find it? According to this rule, the denominator, that is x square, derivative of the numerator, here ddx of e to the power x, minus numerator derivative of the denominator ddx of x square, then denominator square, that is x square whole square. So according to that, x square and derivative of e to the power x is simply e to the power x minus e to the power x, and derivative of x square is twice x, then here x to the power 4, so it equals to, then here twice e to the power x by x to the power 4. That's how we can differentiate, okay. That's in that case we need to use this quotient rule, okay. So hope you have understood this. Let me show you what is chain rule. Okay, suppose you have a function y is equal to f of g of x. That means it is function of function, okay, function of function, not a single function. Suppose we have a function like this, sin x, it is one function. So instead of sin x, suppose there is sin of x to the power 5, suppose, then it is sine of x to the power 5. It is another function of function, okay. So in that case we have to consider this gx as u, okay. We have to consider u is equal to gx, okay. Then dy by dx, derivative of the given function y is equal to fx, f of gx here, derivative of this function, given function dy dx, okay, y means this one, this given function, okay, will be given by du dx and dy du. Derivative of u with respect to x, derivative of u with respect to x, derivative of y with respect to u, okay. So let me show you an example here. Suppose we have, let us take this one as the given function, y is equal to sine of x to the power 5, then let u is equal to x to the power 5, okay. Then let us differentiate with respect to x. Du dx will be equal to, according to this formula, ddx of x to the power n, it gives n into x to the power n minus 1, isn't it? So here 5 x to the power 5 minus 1 is nothing but 4, isn't it? So then again we need to find dy du. When you consider u is equal to x to the power 5, this sine x to the power 5, sine of x to the power 5 becomes sine u, okay. Now you can derive you can find the derivative of this y with respect to u, so that will be du of sine u. We know that derivative of sine x is cos x, so here it will be cos u, instead of x there will be u. So according to the chain rule, according to this rule, dy dx is given by du dx then dy du. Okay, now let us replace this du dx by 5x to the power 4. That's gonna give you 5x to the power 4, and let us replace this dy du by cos u. Okay, this is the result, isn't it? So cos u. So here you see this u is nothing but x to the power 5. U is equal to x to the power 5. Now let us replace this u by x to the power 5, and doing so we will get x to the power 5x to the power 4 cos x to the power 5. So this is our required result. So that's how we can use chain rule to find derivative of function of this form. Okay, so hope you have understood. So in the next video I will show you how to solve the problems of exercise 13.1 of NCERT textbook of mathematics class 11. Okay, because I don't want to make the video too long. Okay, so that's why we will solve the exercise problems in the next video. Okay, so if you like my video, please subscribe to my channel and share my videos. Thank you for watching.